project is designed against the background of increasing food insecurity, particularly in Asia, and particularly for one of the most important commodities, which is rice. Rice feeds over 3 billion people in the world, and nearly 3/4 of a billion of the poorest people depend on rice. It's a networking project because there's a lot of knowledge already available about how to improve rice systems around the world. However, we could really benefit from better exchange of that sort of information, particularly by building the necessary systems analytical capabilities with our younger scientists. We thought that that was a very important project that we could use.
The background of the project was that there's lots of people who work on rice systems, but they're not necessarily well connected with each other, and also the fact that there's people who are very experienced in working in rice systems and other people who are not so experienced. The idea was to bring people together so that the more experienced people can help the less experienced people learn how to do systems modelling and how to address some of the important questions in rice systems.
The project was originally conceptualized to involve Pakistan, India, Indonesia, Japan and Australia. Recently we have also added Sri Lanka to it because as it turned out, there are some very important research activities going on in Sri Lanka that considerably value add to the objectives of the project.
Dry zone is the main component for the agriculture because for the total area of the land of Sri Lanka, 65% of the land area used for the agriculture in the dry zone. The rice is cultivated totally in Maha season because there are a lot of water available in Maha season. And if farmers have a 1 hectare, they totally 100% of land area cultivated in Maha season in rice. But in Jala season, they do not go for that option because of the water scarcity.
Arable land and water are the two principal natural resources in Pakistan. Agriculture is the mainstay of Pakistan's economy, contributing about 21% to its GDP and applying about 45% of the total world labor force. The declining water availability would be the main concern to sustain the increase in rice area and production. Besides water shortage, another major constraint to rice production is the low land population. So in order to improve the resource use efficiency of scarce resources of labor, water and energy, I am investigating aerobic rice system as an option for improving resource use efficiency in rice-based systems of Pakistan. Photoperiod sensitivity complicates the estimation of a large number of required parameters that characterize phenological development and hence impairs predictions. Phenology calibration based on field experiments is especially difficult because of the two main problems: finding the start and end of the photoperiod responsive period and disentangling photoperiod and temperature effects. So the implications of this project are that aerobic rice is potentially an interesting alternate evident from high values of the water productivity and the farmers' positive response to experiment with it. Grain yields are within the target yield. Producing more rice with less water was not possible in this case, but the saved water can be used to irrigate the previously unirrigated area, or there is another option that farmers might sell the saved water to neighboring farmers and raise their income.
So I I used the crop modeling concept to develop a best management practice in aerobic rice system so that the yield level should be up to at least 80% to the flooded system. I used the different scenarios in the rice and different scenarios in maize, and shortlisted the best 4 scenarios in rice and best 4 scenarios in maize, which will give a optimum yield, that means around 80% to the flooded rice. After that, I used the best 4 in the rice and best 4 in the maize and ran in the sequence. To convince the policy makers, we need to extrapolate this data to the watershed scale, or maybe a district, or maybe including a country. So what I did was, after getting this best treatment using crop model, I tried to upscale to a watershed near our Hyderabad called Vargal watershed. So like I just simply have a big numbers to compare what is the advantage of aerobic flooded system in a watershed. See, mostly the irrigation will be pumped using the electric energy. So there is a lot of saving in pumping hours when you go for an aerobic system. So there is some mismatch, actually it should be opposite. So pumping hours will be drastically reduced. Only problem with the aerobic system is the leaching. So if you carefully increase the number of speeds, the leaching can be reduced, the electricity pumping can be an advantage, like countries like India where actually electricity is a big problem. So these type of results can convince the policy makers.
This project, it is having 4 research components, main research components. One is crop weather relations, and another is, second most important is crop simulation modeling or crop weather modeling, and third is pest disease, weather effect on disease and pests and diseases, and fourth is on agroclimatic characterization. These are the 4 important components of this project. Rice modeling, still we are weak. We want to strengthen it also. So here our activities are mostly confined to collection of minimum data sets for rice modeling. So in our network project, I want to introduce EPSIM, and I want to validate EPSIM model.
And rice fallows have become an obvious option, because in the second season farmers are not getting irrigation for the crop, paddy crop, which is all puddled paddy or paddy rice. In that connection, farmers are trying with options like, already an existing option is that a black gram or another pulse called Pillipesra, which is also a phaseol species for fodder purpose. These two are, so if we can contribute something on dryland systems, we can do that.
We are well connected with the planners in day-to-day, even particularly drought monitoring and also planning, crop planning and other things where we can push certain of the issues at policy level, particularly with respect to drought monitoring, so that we can, whatever the research output which we get from this kind of project, we can straight away go to the planners. And this is the holistic approach. Really, everybody is looking at India with respect to weather forecast and its application at the field level. Even Sri Lankan government is also looking at India Meteorological Department to help even Cambodia, Bangladesh and all these countries. They are looking at us to help the governments to come out with a project which can help the farmers to give the advanced forecast and also value addition to the forecast, what needs to be done by the farmers in case of there is some inclement weather and kind of thing. This is the major activity which we are doing.
Actually, I'm here to represent our research center, CCROM. It's Center for Climate Risk and Opportunity Management in Southeast Asia and Pacific, Bogor Agricultural University. This is actually the presentation is prepared by Professor Rizal Nibor. Hopefully, this is still in line with the activities in the APN project.
The Inception Workshop fulfilled several purposes. Firstly, it was a way for people to get to know each other, of getting together, exchange ideas, and actually get to know their colleagues and understand what sort of issues they're working on in different parts of the world.
transferred by putting up several dams into this area, because the river does not come to this area.
So they develop an irrigation area.
So all these irrigation just come from the Mahavali. So there are Mahavali sections. This is the Mahavali which
like more like better than our Indian
conditions. If it is more than 750 millimeters, it is considered as wet. So you
So is it like 900 millimeters?
Yeah, yes. Yeah, it's like 900 millimeters below. It's like we call as rhizome, and more than 1,500 we call as.
The other major objective of the Inception Workshop was to actually design some small projects that can be achieved with just some small funding. The objective being there to value add to a lot of the other activities that are happening around the world in improving rice systems.
Once we've talked about what the big issues are, we need to identify what can we do, what are the research questions that we can address in helping to improve the productivity and sustainability of rice systems in Asia.
We just finished the Inception Workshop today as we speak, and I'm extremely pleased that we managed to really get a tight network of scientists from across the region together, involving senior scientists as well as some fairly junior people, so that the capacity building is basically ensured simply because of the network that we have managed to establish. The other major outcome is that we have agreed on 3 of the research priorities that will be addressed through various projects. And these range from looking at improving resource use efficiency in rice systems to doing a yield gap analysis and to investigate the feasibility for an index insurance for rice.
Well, I think the Inception Workshop went really successfully. We had a lot of people from different countries with different levels of experiences, and it's important that people, to begin with, can be able to talk on the same level and relate to each other, because the idea is to form a team that can work together over the next few years. And from that point of view, it was really successful. So we have a good team of people who are interested, who are keen to address some of these issues, and we also managed to formulate what some of the key projects will be as part of the project. So I think it's been a great start to the project, and we had a really nice time in Sri Lanka.
I thought it was a highly successful workshop. The 3 project proposal drafts that were developed seemed very well considered and really good. And I liked the atmosphere of the workshop. Was fantastic. Everyone seemed to really connect and bond, and I think it will be a very positive and fruitful project over the next 3 years.